The intrinsic molecular structure of polymers dictates their mechanical properties. With engineering materials like nylon and carbon fiber reinforced composites offering superior tensile strength and rigidity compared to commodity plastics such as PLA or ABS. Material selection significantly impacts thermal stability. For instance, PEEK exhibits exceptional high-temperature resistance and chemical inertness, making it suitable for demanding aerospace applications, unlike PLA which deforms at relatively low temperatures. Elastomeric materials such as thermoplastic polyurethane, TPU, provide high elasticity and impact absorption, fundamentally differing from rigid polymers like PETG or ABS which are chosen for their structural integrity and dimensional stability. While most 3D printing polymers are synthetic and persistent, polylactic acid, PLA, stands out as a bio-derived and potentially biodegradable option, offering a more sustainable alternative for specific applications. The rheological properties and coefficient of thermal expansion vary greatly among materials, rendering certain polymers like ABS and polycarbonate more prone to warping and delamination during printing compared to the more forgiving PLA. The chemical compatibility of a 3D printed part is directly determined by its material, with some polymers exhibiting high resistance to solvents and acids, crucial for industrial components, while others degrade rapidly upon exposure. Material choice impacts post-processing capabilities. For example, ABS can be smoothed with acetone vapor, a technique generally ineffective for materials like PETG or nylon, necessitating different finishing methods. For medical and food contact applications, materials must meet stringent biocompatibility standards, with specialized grades of ABS, PETG, and PEEK engineered to prevent adverse biological reactions. Unlike general-purpose filaments, different materials possess varying degrees of resistance to UV radiation and environmental degradation. ASA, for example, offers superior weatherability compared to ABS, making it preferable for outdoor applications. A critical differentiator is the cost-performance trade-off. High-performance engineering polymers like Ultem offer superior strength-to-weight and thermal properties at a significantly higher cost than common prototyping materials like PLA or ABS.